Find the exact value of each expression if it is defined. Sine inverse of sine of 3 pi over 4 and sine of sine inverse of 5. For the first part, this is a composite of functions, so we would have to evaluate the inner function first. We will first evaluate sine of 3 pi over 4. Remember that on the unit circle, in the first quadrant at pi over 4, the coordinate of the terminal point is root 2 over 2, comma root 2 over 2. We are interested in the coordinate at pi over 4 because the denominator of this input is 4. 3 pi over 4 is in the second quadrant, 1 pi over 4, 2 pi over 4, and then 3 pi over 4. In the second quadrant, x is negative and y is positive. Using symmetry, we see that x at 3 pi over 4 is negative root 2 over 2 and y is root 2 over 2. Sine of 3 pi over 4 is therefore root 2 over 2 because on the unit circle, sine is the y coordinate. Now, sine inverse of root 2 over 2 is a number in the first and the fourth quadrant. We would have to restrict the domain to the interval negative pi over 2 to pi over 2 only. And so the answer is not going to be 3 pi over 4 because 3 pi over 4 is outside of this restricted domain. But by looking at this unit circle, we see that sine inverse of root 2 over 2 is the angle pi over 4. So the answer is simply pi over 4. Note that every time we have an inverse expression, we would ask ourselves this: what is the number t such that sine of t equals root 2 over 2? And this is the tricky part. We would have to use the unit circle to read it off. Sine of what value is root 2 over 2? That value t needs to be pi over 4. For the second part, we would evaluate the inner function first, which is sine inverse of t. And so the question is now, what is t such that sine inverse of 5 equals t, or what is t such that sine of t equals 5? Sine of a number has to be between negative 1 and 1, and so there's no such t at all. We conclude that the answer or the value is not defined because sine inverse of 5 is not defined. There is a very important observation here. It is true that the function and its inverse would cancel out. The composite of the function and its inverse would cancel out, but only on the proper domain. We cannot just simply cancel sine inverse and sine to get 3 pi over 4 as the answer because 3 pi over 4 is not in the domain of the restricted sign. Similarly, the domain of sine inverse is a number between negative 1 and 1. 5 is not included in that interval.